Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
Soil is the top layer of the earth. Without soil, there'd be no life on our planet. So we're here to answer your questions about soil, because there's a lot more to the study of soil than just dirt. Stay tuned. Science Trek is next. Hi, I'm Joan Cartan Hansen, and welcome to Science Trek. And welcome to the Idaho Museum of Natural History on the Idaho State University campus here in Pocatello. We're here to answer your questions about soil. But before we do, let's learn a little bit more. Soil is the top layer of the earth. It's made of air and gas, bits of rock, minerals, water, decaying plants, and tiny microbes. Soil forms in different layers on the earth. When soil scientists study layers of soil, they call it studying the soil profile. Topsoil is the layer you see, the layer you typically walk on. It contains dark organic material, which is made up of decayed plant and animal matter. Topsoil can be about 6 inches thick. Under topsoil is subsoil. It's from several inches to several feet thick. It looks lighter because it contains less humus, is more tightly packed, and has slightly bigger pieces of rock. Next is the fragmented rock layer, or parent material. Nothing grows at this layer. It's made of rock particles, sand, clay, salts, and minerals. At the deepest level is solid bedrock. This is a layer of rock from which soil begins to form. Soil is created over lots of time. Rocks form when volcanoes erupt or when sands get compressed. Weathering from wind, ice, and rain breaks rocks into smaller parts. Plants grow in the cracks caused by erosion, creating more holes for air and water. They also drop leaves, which decay. Animals leave waste products behind. Bacteria and fungi help break down dead plant and animal materials into smaller pieces. These combine with rock particles to make soil. Now there are different types of soil. The type depends upon the original parent material, how big the rock particles are, the climate, and what else is in the mixture.
Clay is the smallest soil particle. Clay clumps because it can hold water better than some other types of soil.
Silt is powdery and soft to the touch and retains water well.
Sand is the largest soil particle. It is the least resistant to weathering.
Loam has the best soil for growing plants. It is an even combination of sand, silt, and clay particles with organic materials.
There are over 25,000 different named soils in the United States. Soil scientists are trained to be able to identify different types of soil and what they mean for the environment. Soil is very much alive. 1 tablespoon of soil contains more microbes than there are humans on Earth. Insects, bacteria, earthworms, and other creatures live in soil. Larger animals do too, like badgers and snakes. Soil filters our water, holding back contaminants and taking out impurities. Soil is used in construction and provides the foundation upon which our homes and businesses are built. And importantly, plants need soil to provide them with minerals and nutrients. Soil scientists help farmers understand what plants to grow and how to improve the soil to increase their crop yields.
Soil is an essential natural resource. It's food for some animals, home for others. Soil cleans our water, provides nutrients for plants, and gives us a place to live. So learn about soil. Dig in.
And joining me now to answer your questions about soil are David Huber, PhD candidate in biology at Idaho State University, and Carla Ravernack, a soil scientist with the Natural Resources Conservation Service. Thank you both for being here.
Great, thank you for having us.
Thank you.
Okay, let's go to your questions.
Hi, my name is Caden, and I go to Kamiah Elementary School in Kamiah, Idaho. My question is, how is soil formed?
Well, sometimes it starts with a rock, and that rock might get rained on or frozen or falls and somehow breaks. It breaks into smaller pieces until you have a lot of little rock grains. And then you would add to that some organic matter, maybe a leaf that blew in and starts to break down, or a plant that grew and died, maybe some animal waste. And over thousands of years, those mix, those rock grains and the organic materials, and then also some water and some air in between those grains, and that mixture is what we call soil.
Hi, my name is Mason. I go to Whittier Elementary, Boise, Idaho. And my question is, are there more creatures that live in the dirt or more creatures that live on land on Earth?
So yeah, there's estimated to be 10 to the 19th different species of bacteria and other organisms living in the soil. So that's, I think, 10 quintillion different species that live in the soil, compared to on land there's close to 10 to the 9th, which is maybe or 10 to the 7th, which would be 10 million different species. So there's quite a few more that live in the soil than live on land.
Ryan asks, are there different kinds of soil?
There's different types of soils. Across the entire world, different countries use different systems for describing soils, but here in the US we have 12 main types of soils that we call orders. And if you then describe those soils in detail down to their more fine properties, you can actually come up with 15,000 to 20,000 unique different soils here in the United States alone.
Hi, my name is Jill. I go to Oahe Harbor Elementary School. My question is, how deep does soil go?
Well, that could be variable. Your soil could be down to a few centimeters of soil thickness, or it could be meters thick. It's going to depend on your position on the landform, how resistant to weathering your parent materials are, or just the age, the time that that soil has had to weather in place.
Curtis would like to know, how many layers of soil are there?
Well, when we talk about layers, soil scientists are usually describing the horizons. So the horizons are those unique layers, usually parallel to the surface, and they're different from the layer above or the layer below. And so you might also be thinking of the three layers called the topsoil, subsoil, and parent material. And those are just broader categories of the layers. And the topsoil is the part on the surface. It usually has more organic material in it, so it's a little darker in color. It's the crumbly, soft part that you might plant your garden into. Now beneath that is what we call subsoil, and that's just a little lighter in color because it has less organic matter. It might be a little denser. And then below that is your parent material. Now the parent material is the unweathered sediments that the soil is forming from. It could be rock, it could be windblown sands, it could be organic material. So there are the three broader layers and then the horizons within.
Hello, my name is Aaron and I am from Basin Elementary. And my question is, how does soil give nutrients to plants?
Well, soils store a lot of the nitrogen and phosphorus and potassium and other nutrients that plants need in them, both in the solution and attached to the clay and organic particles that are in the soil. And when the water moves through that soil, it picks up some of those nutrients and moves it to the plant roots, where they are able to take it up and use it for their biomass and for the processes that they need.
Hi, my name is Rihanna, and my question is soil alive?
Oh yes, there are parts of the soil that are very alive. There are so many microorganisms too small for the eye to even see, the bacteria, the protozoa, nematodes, fungi, and if you can believe it, in 1 teaspoon of soil there are 1 billion bacteria, so soil is definitely alive.
Hello, my name is Alex and I'm from Basin Elementary. My question is, how long does it take for something to break up and make soil?
So how long it takes a soil to form will depend on a couple of things. Like if you're in a climate that's warm, all of those soil forming processes are a little faster. If it's warm, if there's more moisture in the system, or if your material is less resistant to weathering. Now, on the opposite side, if it's colder or drier, or your material is more resistant to weathering, then it's going to take longer for that soil to form.
One shovelful of soil can contain more different kinds of organisms than the total number of creatures who live on top of the ground. And considering what soil is made of, when you take a step in the forest, you're being held up on the backs of thousands of bugs.
Justin would like to know, why is soil brown?
So soils are brown usually because of the organic inputs that from dead plant or animal material that gets incorporated into the top of that soil layer. Soils, though, don't have to be brown. They can be all kinds of colors: reds, blues, purples, pinks, whites, all kinds of colors. But what makes them brown is typically that organic matter.
I'd like to add to that, David, that another pigment in the soil can come from iron oxide. So the iron oxides might be like, think of the rust on your bike. Those give soil a reddish brown color. And then another place color can come from in your soil is from the parent material. So if you think about maybe a clean sand grain on the beach, it's been stripped of all organic matter or iron oxides or other things that can color the soil, and what you're seeing is the natural color of the parent material. It might be a whitish or a yellowish color.
Hi, my name is Evan. I go to Hawaii Harbor Elementary School. My question is soil different from dirt?
Oh yes. So soil is the scientific term that we would use to describe that intact part of the Earth's crust that supports plant life. Dirt, I usually think of as a word that we use to describe the soil once it's been removed from the Earth's crust and maybe out of place. It's lost that sense of origin. Dirt might be what you use to describe what's under your fingernails or on your boots.
My name is Zach, and how can you determine the age of soil?
Well, there's a number of different ways to figure out how old a soil is, how developed it is, how the horizons look. There's also ways that we can look at the carbon that's in that soil and use some sophisticated techniques to determine how old that is, and how deep it is in the profile will tell us how old that soil is.
We can also estimate whether it's a relatively young or mature soil just by looking at the horizons. If those horizons if there's a lot of horizons, if they're really thick, and if they're really different from the one above or below, then that soil's probably had a little more time to form and mature.
Carson would like to know, how was the Earth created?
Well, I would say the most widely accepted theory is the one where a cloud of gas and dust in space started to collapse in on itself from gravity. The sun was already in place, right? We're talking about the Earth here. So when the gravity collapsed that cloud of gas and dust, the heavier elements sunk to the center, and that became the core of our Earth. Now the lighter ones gravitated to the outside and formed the crust.
Hi, my name is Weston, and I go to Hawaii Harbor Elementary School. My question is, do other planets have soil?
Well, you might hear scientists use the term soil when they're differentiating between rocks or the finer material on another planet, but we usually only use the word soil on Earth because that's where it supports plant life.
So what we would call that material on other planets then would be called regolith, I think is what the term is, what we would use.
Matthew would like to know, does soil help plants in the desert?
Soils in deserts are going to support plant life just like they do here. They're going to provide water and nutrients to those plants. In deserts, however, there might be certain conditions that help those plants keep hold of that water better than in other areas. If you have coarse-grained sand on the surface of those soils, they act kind of like a mulch, like the wood chips that you'd put in your garden, and they prevent that water from leaving the soil through evaporation, which means that it's available for plants to use.
Hi, my name is Mason, and I go to Hawaii Harbor Elementary School. And my question is soil the same all over the world?
No, soils can vary quite a bit, from locally, just a few meters or a few feet away, to soils that are on the other end of the world that are millions or even billions of years older than what we have here. So no, soils are different at all different scales all over the world.
Karen would like to know, how much water do you put on soil to make crops grow?
Well, that's going to depend on what you're growing, what the water needs are of that plant, and then you also want to determine how much water is already stored in the soil, and those two things can help you determine how much additional water you might need to add to the system.
Hi, my name is Salma, and I was wondering what was the nutrients in the soil?
Well, there are a lot of nutrients that the plants get from the soil. We break them into primary, secondary, and trace nutrients. The primaries are just the ones that they need in the largest amounts, like the nitrogen, the phosphorus, the potassium, but they're all equally important, and they all have different jobs within the plant. Some act as the building blocks for the cell walls, and some help the plant breathe or make energy.
You don't have to wait until you're in college to learn how to become a soil scientist. These Kuna High School students are about to show off their soil scientist skills. They're competing in the Idaho State Land and Soil Evaluation Career Development Event Contest.
Kids here today are involved in a contest of judging soil and land to help determine its best use and to help determine whether the land is suitable for agriculture or how suitable, what kind of crops or tillage should be here. We also have 2 sites that they judge for a home site to determine the suitability for building a home with the appropriate structures that go with that.
In the competition, the teams of 5 people investigate each of 6 pits dug into the ground. They examine the soil by looking at the soil horizon, the layers of topsoil and subsoil.
I go through and I'm checking for the erosion loss. So I take my soil picking tool and you pick through the dirt until it gets where it's a change in how you feel it or what it's going on.
They also classify the soil by doing something called texturing.
We grab the soil and we're trying to find what the different sizes are. And so there's sand, which is the largest, then silt, and then which is the middle one, and then clay. Usually you want a silt because it's not too big and it's not too small. And so what we do is we get it wet because you can't really tell, because sometimes the clay will like build up with each other and they stick together a lot. So you have to break it down using the water. And then for sands it would be really gritty, and then for silts it's really, really smooth, and then clay will stick together a lot, so it'll be hard to move around, and it will stick together really well, and that's how we can tell the difference.
The students also determine the slope of the land, the angle at which the land falls or climbs. Knowing the slope helps determine water runoff and whether the soils are vulnerable to erosion. That's important to know, especially if you're picking a place to build a house.
And then the other things that we do is they give us numbers on the placard, which is a thing, board with a bunch of information on it. And there are nutrients that are found in fertilizers, and they tell you how much is in the soil. And so then knowing whether or not the soil on a pH scale is below 7 or above 7, you can determine what types of nutrients you need. And so they tell us that how many nutrients there are, and we determine whether or not they need to add more or not.
Most of these kids come from an agricultural background, so they're interested in learning this to help them maybe go back and run their own operation at some time. The kids that don't do that, they're learning about how to judge a site for suitability for a home.
The students mark all the required information down for each pit on their own sheets. It takes real skill to be able to answer all the questions, and students from all over the state compete. Each team member sheets are scored, combined, and the top 2 scoring teams will go on to represent Idaho in the national competition.
Yeah, I think it's a good learning experience, and you get to go out and you get to meet new people and you get to experience things you wouldn't normally experience.
I'm doing this because we have a class for it, but also to gain more knowledge about agriculture and other things, so that way I can potentially do things on my own instead of having to hire someone to do it, and also possibly pursuing a profession in agriculture.
The team from Kuna didn't win today's competition, but they did learn something important.
It's not just dirt, there's more to it.
If you're interested in competing in a future land and soil evaluation competition, contact your local Future Farmers of America or 4-H representative. Okay, let's go back to your questions.
I am Jackson. I go to Hawaii Harbor Elementary School. My question is, do all plants need soil to grow?
Most plants need to grow in soil, but not all of them. Some plants are parasitic, so they will actually grow on other plants and get their water and nutrients from those plants. And there's even plants that, epiphytes, that live on other plants, but they actually get their water and nutrients from the air, essentially water, rain, and deposition or dust that filters down on them. They'll get their nutrients and water from those. So not all plants have to live in soil, but most do.
Adriana asks, how would a worm produce fertilizer?
So what worms do in the soil is they eat the organic matter and also other microbes, and they excrete them back into the soil. They'll also shred and bury little bits of plant material into the soil. And these things aren't necessarily the fertilizer, but what they do is they prime the soil for the mineralization process, which is how the nutrients turn into an available form that the plant can use.
Hi, my name is Emily, and I go to Hawaii Harbor Elementary School. My question is soil under the ocean?
Yes, if it's supporting plant life, whether it's under the ocean or under a lake or even a stream, we would call it soil.
Hello, my name is Ray and I am from Basin Elementary. My question is, if you put extra water in soil, will plants grow faster?
Well, that depends on how much extra soil or extra water you add to those soils. If you add enough that the plant can use that water, then that's great. But if you saturate the soil, what that ends up doing is preventing oxygen to get to those roots, and those cells in those roots still need oxygen to process and metabolize. And without that, those roots will slowly die, and then that plant won't be able to take up all that water and other nutrients that it needs to live.
Cameron asks, what happens to soil after it freezes?
Well, there's a couple things that can happen to soils when they freeze. So you have something that can happen to the microbes and the biology of the soils, and you can have something that happens to the physical part of the soil. So for the microbes, the living part, when they freeze and then thaw, what that does is it breaks open those cells, and their innards spill out into the soils, and the microbes that are still alive, they'll use those materials to live and they'll eat those. So that's one thing that'll happen when the soils freeze. The other thing is when that ice forms, it expands and it'll push those soils up a little bit, causing something called frost heave. And that soil will do several things. It can damage roads, and or sidewalks, foundations. It can also cause an increase in erosion because that soil that pushes up is actually looser and easier to run off.
Hi, my name is William and I go to Kamiah Elementary School. And my question is, why does rich soil make plants and crops grow better?
So if you're describing a soil as rich, you're probably thinking of a soil that has a lot of organic matter in it. And organic matter helps the plants grow because it increases the amount of water that soil can hold. It also contains a lot of nutrients in it, and it also holds those nutrients in a form that is more available to the plant. So that's probably why it looks like a rich soil grows plants really well.
Ryan would like to know, how do you fertilize soil?
Fertilizing a soil usually means you're adding something to it. You're adding something that soil needs or doesn't have much of. So the best way to fertilize your soil, the most important part, is to make sure that you test the soil first so that you know what it has and what you're going to plant in it and what that plant needs. And so in this way you can make sure that you're adding only what the soil needs and in the form that is most available to the plant and at the time that the plant needs it. There are different forms of fertilizer. You could use compost from your kitchen or garden waste, or it could be an inorganic form that might be a little pellet that just contains the nutrients.
Adriana asks, what makes soil so soft?
Well, if you think a soil is soft, it might be some of the organic matter you're feeling in there. If you think of maybe a pile of grass clippings in your lawn, if you added that, incorporated it to your soil, it would help it feel softer. But we also have a soil particle called silt that can feel soft to the fingers. It feels a lot like flour or ash, and so that can make a soil feel soft.
Madison asks, soil is food for plants and trees. If soil wasn't here, what would happen?
In a nutshell, I would say it's the end of humans. If we don't have soil, we have no way to grow food for ourselves or for the animals that humans eat. So I don't know what would happen to the rest of the civilization, but I don't think we'd be here.
David, before we run out of time, why did you pick a job working with soil?
I picked working with soils when I was 18. I traveled down to Antarctica, completely unrelated to science, and I was working down there, and I saw a talk by a woman who was giving a presentation on her research looking at nematodes and mites, which are organisms that live in the soils down there. A very simple system, and I was amazed that they could live in these frozen soils, and they had all this diversity, and it was absolutely wonderful. I couldn't wait to get back, and it turned out this woman, this researcher, was at the university in my hometown, and so it worked absolutely perfect. And from that point on, I wanted to work with soils, physics of soils, the chemistry of soils, and the microbiology of soils. It was all wonderful.
Carla, if someone is interested in getting a job in this field, what should he or she study in school?
Well, I think it would be important in high school to keep your sciences strong, your math and your earth sciences like chemistry and biology, and then maybe when you get to college you'll probably want to specialize a little more, and depending on which kind of field of science you choose, you may need more or less math or other more specific sciences. But I would just say don't be discouraged. Anyone can be a scientist.
Thank you. I'm sorry we've run out of time. I appreciate you both answering questions today.
Thank you for having us.
It was our pleasure.
My thanks also to the folks here at the Idaho Museum of Natural History for hosting us. Do you have a question for one of our future shows? You can email it or send it as a video question, recorded on your cell phone, tablet, or webcam. Or if you're an educator, we'll even lend you a camera. And if you send in a question, you and your class can win prizes. Our last prize winner was Ella in Mrs. Lindquist's class at Basin Elementary in Idaho City. So to find out about today's topic, go to the soil section of the Science Trek website for facts, links, lesson plans, and more, or watch Science Trek the web show. So send in your questions, and each week, check out my blog for the latest science news for kids. You'll find it all at idahoptv.org/science-trek. Thanks for joining us. We'll see you next time on Science Trek.
Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
If you want to learn more about this topic or watch our videos, check out the Science Trek website at idahoptv.org/science-trek.